This is the fourth video in the Integrated Data Viewer Intermediate Topics series. In the past two videos, we created several figures for isentropic analysis that were designed to be viewed from above. Now we'll make a figure that should be viewed from the side to investigate the relationships among jet streaks, isentropic potential vorticity, and isentropes. I've put a data file in the catalog for this lesson. The easiest way to get it is to copy this link into the URL data chooser. You can copy the link from the description. The file contains publicly available ERA5 reanalysis data from the Copernicus Climate Data Store. The ERA reanalysis series is great for plotting. You can specify the resolution and the variables that you want to be included in the online data portal to find exactly what you need. To use this file, though, you'll need to set aliases for the variables. We can do this by right-clicking on each variable name and selecting Add the name of the variable as alias for option. Remember this short name that pops up. Type it on a new line in the alias editor. We just repeat this for each parameter. Once that's done, the IDV will give you the option to select derived parameters after you reload the dataset. You'll never have to redefine these aliases as long as the IDV is continuously installed on your machine. Let's start with the jet streaks. One of the derived momentum quantities is scalar wind speed. We can take that and plot an isosurface. The IDV will try to guess what isosurface you want plotted based on the data, but 20 meters per second is probably a good value for this altitude range. Next, we plot the isentropes. I want to see the jet streaks already on my screen go through the potential temperature cross-section. This means that I need the isentrope display to show up on the map view and not in the transect view. The map view is already in the active pane, so this won't be a problem unless you decide to select the pane in another view window. It's best to avoid matching the display region when you use cross-section plots. Every time you adjust the display, the cross-section resets to its default position. Isentropes are conventionally plotted as plane contours. Following what seem like arbitrary plotting conventions may seem pointless, but it can make communication much easier. Easily understandable figures add value to your research or presentation. We'll move the cross-section so that it crosses the jet streak. If you toggle 3D and switch to the side view, you can actually see the jet streak intersect the cross-section. This does hide some of our potential temperature data, but you can check what's behind the jet streak by toggling the isosurface visibility. It's pretty clear that our data doesn't reach the top of the wireframe box. We'll be able to get more detail if we stretch the data. To do this, you click on the little vertical scale icon and set the maximum value to 4,000 meters. Now the isentropes are too widely spaced to see much detail. We can fix this by decreasing the contour interval. Now we can see a lot more detail for the same cross-section. Notice that there is a right side to view the cross-section from if you want to be able to read the numbers. From one side, they look normal. From the other side, they're backwards. Now we can make our cross-section of isentropic potential vorticity. The colors here aren't as distinct as I would like, so I'm going to adjust the range for the color bar. And in addition to the change range option, you can also change the range using this screen. Still, it didn't change as much as I would have liked it to, so I'll try setting the maximum value to 4. It's better, but still not great. I'll probably come back and work on this a little bit more later. You'll notice that the cross-sections are nearly perpendicular to each other. Depending on how you're using this figure, you probably want them to be parallel and in the same location. For them to share an axis, you can go to each cross-section, under Edit, set Sharing to On. At first you won't see any difference, but as soon as you move one of the cross-sections, both of them will move. This makes it really easy to adjust your figure without having to deal with lining things up again. It's still hard to see the isentropes on the IPV cross-section, so I'm going to work a little bit more on tweaking the colors. Now we can see the isentropes pretty well, and if we go back to the IPV cross-section, I'm going to narrow the color range a little bit more to make the variations more distinct. Displaying the data like this makes it easy to see relationships between variables. We can tell pretty easily that the jet streaks tend to be above steeply slanted isentropes. If I were teaching, I could explain thermal wind without this figure. Adding this visual component would make the thermal wind equation much more intuitive and the concept of thermal wind much more concrete for the students. As always, please visit unidata.ucar.edu or email support-idv@unidata.ucar.edu if you have any questions.